Part 1. What is volume? Let's start with a simple idea. You already know that different things take up space. A pencil takes up a little space. A school bag takes up more space. A cupboard takes up even more space. And if your school bag is full of books, water bottles, worksheets, and maybe one snack that you forgot about last week, then you can really feel that space is being used. Today, we are going to learn about volume. Volume means how much space an object takes up. It can also mean how much space is inside an object. For example, a box has volume because it takes up space. A bottle has volume because it can hold water. A lunchbox has volume because it can hold food. A room has volume because there is space inside the room. A drawer has volume because you can put things inside it. So, when we talk about volume, we are not only looking at the outside. We are thinking about the space taken up by the whole object, or the space inside it. Here is a simple way to imagine it. If you have an empty box, there is space inside the box. If you put toy blocks inside, the blocks take up some of that space. If you keep putting in more and more blocks, the box will become full. The amount of space inside the box is related to volume. So remember this first idea. Volume means how much three-dimensional space something takes up. It is not just flat space. It is space with length, width, and height. A piece of paper is very thin, so we often talk about its area. But a box is not flat. It has length, width, and height. So we can talk about its volume. Volume is about solid space. It is the kind of space that can be filled, packed, or used. Part 2. Area and volume are different. Before we learn how to calculate volume, let's make one thing clear. Area and volume are not the same. Area is about a flat surface. Volume is about a three-dimensional object. Think about a phone. The phone screen has area. It is the flat front part that you touch. But the whole phone has volume because it also has thickness. Think about a table. The top of the table has area, but a drawer under the table has volume because you can put things inside it. Think about a wall. The front surface of the wall has area, but a room has volume because there is space inside the room. A simple way to remember this is, area is often about covering. Volume is often about filling. If you cover a book with wrapping paper, you are thinking about area. If you cover a table with a tablecloth, you are thinking about area. If you paint a wall, you are thinking about area. But if you fill a bottle with water, you are thinking about volume. If you fill a box with toys, you are thinking about volume. If you fill a fish tank with water, you are thinking about volume. So, area is like asking, how much flat space do I need to cover? Volume is like asking, how much space can this object hold? Or, how much space does this object take up? Here is another example. Imagine a slice of bread. The top of the bread has area. If you spread jam on the bread, you are covering the area. But if you look at a whole loaf of bread, it has volume because it is not flat. It has length, width, and height. And yes, a loaf of bread also has another important use, making sandwiches. But in maths, we are mainly interested in the space it takes up. So remember, area is flat. Volume is solid. Area uses squares. Volume uses cubes. Part 3. Understanding cubic centimeters. Now let's talk about the unit for volume. When we measure length, we may use centimeters or meters. When we measure area, we may use square centimeters or square meters. When we measure volume, we use cubic units. Why? Because volume is about cubes. Let's begin with 1 cubic centimeter. 1 cubic centimeter is a very small cube. This small cube is 1 centimeter long. It is 1 centimeter wide. It is 1 centimeter high. So, 1 cubic centimeter means a tiny cube with length, width, and height all equal to 1 centimeter. Try to imagine a tiny cube. It may be like a very small dice. It may be like a small sugar cube. It may be like a small building block. It is not just a flat square. It is a little cube that takes up space. This is important because volume is not counted by flat squares. Volume is counted by cubes. If an object can hold 10 of these tiny cubes, its volume is 10 cubic centimeters. If an object can hold 50 of these tiny cubes, its volume is 50 cubic centimeters. If an object can hold 100 of these tiny cubes, its volume is 100 cubic centimeters. Of course, in real life, we do not always put tiny cubes into every object. That would take too long, and your family may start asking why there are tiny cubes all over the house. But imagining small cubes helps us understand what volume means. Cubic centimeters are useful for smaller objects. For example, we may use cubic centimeters for a small box, a dice, a rubber, a small toy block, a pencil case, or a small food container. If the object is small enough to hold in your hand, cubic centimeters are often a good unit. So remember, 1 cubic centimeter is a tiny cube. It is useful when we measure small objects. Part 4. Understanding cubic meters. Now, let's move from a tiny cube to a much bigger cube. This unit is called 1 cubic meter. 1 cubic meter is also a cube, but this cube is much larger. It is 1 meter long. It is 1 meter wide. It is 1 meter high. So, 1 cubic meter means a large cube with length, width, and height all equal to 1 meter. Try to imagine a big box. The box is about 1 meter from left to right. It is about 1 meter from front to back. It is about 1 meter from bottom to top. The space inside that big box is 1 cubic meter. That is quite large. It is much bigger than 1 cubic centimeter. You can imagine a large storage box. You can imagine the space under a table. You can imagine a big washing machine box. These may help you picture the idea of 1 cubic meter. We use cubic meters for larger spaces or larger objects. For example, the volume of a bedroom may be measured in cubic meters. The volume of a classroom may be measured in cubic meters. The space inside a lift may be measured in cubic meters. The volume of a large cupboard may be measured in cubic meters. The amount of air inside a room can also be described in cubic meters. Now, choosing the right unit is important. If we measure a small dice in cubic meters, the number will be very tiny and difficult to understand. That is not useful. If we measure a whole classroom in cubic centimeters, the number will be very, very large. That is also not friendly. It would be like counting rice grains one by one to know how much rice is in a big bag. You can do it, but maybe you should not. So we choose a unit that matches the size of the object. For small objects, use cubic centimeters. For large objects or large spaces, use cubic meters. Part 5. How to find the volume of a cuboid. Now we are ready to learn how to find volume. Let's start with a cuboid. A cuboid is like a rectangular box. A shoebox is like a cuboid. A tissue box is like a cuboid. A lunchbox may be like a cuboid. A pencil box may be like a cuboid. A cupboard may also be like a cuboid. A cuboid has three important measurements: length, width, and height. Length tells us how long it is. Width tells us how wide it is. Height tells us how tall it is. To understand the volume of a cuboid, imagine filling the box with small cubes. Let's say the bottom of the box can fit 4 cubes in one row, and there are 3 rows. So, the bottom layer has 4 times 3 cubes. 4 times 3 equals 12. That means the bottom layer has 12 cubes. Now, imagine the box has 2 layers. The first layer has 12 cubes. The second layer also has 12 cubes. So altogether, the box has 24 cubes. That means the volume is 24 cubic units. This is the key idea. Volume is like counting cubes in layers. The bottom layer tells us how many cubes are in one layer. The height tells us how many layers there are. So, for a cuboid, we use this rule. Volume equals length times width times height. This rule is not magic. It is just a faster way to count all the cubes inside the cuboid. Length times width gives us one layer. Then we multiply by height to count all the layers. Let's try a clear example. Imagine a small box. It is 6 centimeters long. It is 4 centimeters wide. It is 3 centimeters high. First, find the bottom layer. 6 times 4 equals 24. So the bottom layer has 24 cubic centimeters in one layer. Then look at the height. The height is 3 centimeters. So there are 3 layers. 24 times 3 equals 72. So the volume is 72 cubic centimeters. This means that if we use tiny cubes and each cube was 1 cubic centimeter, 72 of those tiny cubes could fit inside the box. So remember, for a cuboid, volume equals length times width times height. Length, width, and height are all important. Do not forget the height, because a box is not flat. Part 6. More cuboid examples and common mistakes. Let's practice with another example. Imagine a pencil box. The pencil box is 20 centimeters long. It is 7 centimeters wide. It is 3 centimeters high. To find its volume, we multiply the length, the width, and the height. 20 times 7 equals 140. 140 times 3 equals 420. So the volume is 420 cubic centimeters. This tells us how much space is inside the pencil box. A larger pencil box has a larger volume. A smaller pencil box has a smaller volume. If the pencil box is longer, the volume becomes bigger. If it is wider, the volume becomes bigger. If it is taller, the volume also becomes bigger. That is why volume depends on 3 measurements, not just 1 or 2. Now let's talk about a common mistake. Some students see a box and only multiply length and width. For example, a box is 5 centimeters long, 4 centimeters wide, and 3 centimeters high. Some students may only calculate 5 times 4. 5 times 4 equals 20. But that only tells us about the bottom layer. It is like looking at the floor of the box, but forgetting that the box has height. That answer is not the volume of the whole box. To find the full volume, we must include the height. So we calculate 5 times 4 equals 20. Then 20 times 3 equals 60. The volume is 60 cubic centimeters. Here is a simple way to remember it. If you only use length and width, you are thinking about a flat layer. If you use length, width, and height, you are thinking about the whole box. Volume needs all three: length, width, and height. So, when you find volume, do not stop too early. Do not just find the bottom. Count all the layers. A cuboid is like a stack of layers. The taller it is, the more layers it has. The more layers it has, the greater the volume. Part 7. How to find the volume of a cube. Now let's look at a cube. A cube is a special cuboid. It still has length, width, and height, but all three are the same. A dice is a good example of a cube. Some toy blocks are cubes. Some gift boxes are cubes. Some ice cubes are close to cubes. For a cube, every edge has the same length. So if one side is 4 centimeters, then the length is 4 centimeters, the width is 4 centimeters, and the height is also 4 centimeters. That makes the cube easier to work with because we only need to know one side length. To find the volume of a cube, we use the same idea as a cuboid. Volume equals length times width times height. But since all three measurements are the same, we can say volume equals side times side times side. Let's try an example. A cube has a side of 4 centimeters. So the length is 4 centimeters. The width is 4 centimeters. The height is 4 centimeters. 4 times 4 equals 16. 16 times 4 equals 64. So the volume is 64 cubic centimeters. This means 64 small cubes, each with a volume of 1 cubic centimeter, can fit inside that cube. Let's try another example. A small cube has a side of 2 centimeters. 2 times 2 equals 4. 4 times 2 equals 8. So the volume is 8 cubic centimeters. One more example. A cube has a side of 5 centimeters. 5 times 5 equals 25. 25 times 5 equals 125. So the volume is 125 cubic centimeters. For a cube, the rule is simple. Volume equals side times side times side. But remember what it means. We are still counting cubes. The formula is just helping us count faster. Part 8. Choosing the right unit. Now let's look again at when to use cubic centimeters and when to use cubic meters. This is important because the right unit makes the answer easier to understand. Use cubic centimeters for small objects. For example, a dice, a small toy block, a rubber, a small box, a pencil case, a small food container, or a small gift box. These things are not very large, so cubic centimeters make sense. If I say a small box has a volume of 120 cubic centimeters, that sounds reasonable. But if I say it in cubic meters, the number may be very tiny and not easy to understand. Now use cubic meters for larger spaces. For example, a bedroom, a classroom, a lift, a large cupboard, a storage room, or a big water tank. These spaces are large, so cubic meters make more sense. If I say a classroom has a volume of 150 cubic meters, that is much easier to understand than using a huge number of cubic centimeters. So, when choosing the unit, ask yourself, is the object small, like something I can hold? Then cubic centimeters may be suitable. Is it large, like a room or a big cupboard? Then cubic meters may be suitable. Here is a simple picture in your mind. Cubic centimeters are for small cubes. Cubic meters are for big cubes. Small object, small unit. Large space, large unit. That is the friendly way to remember it. Part 9. Final review. Let's put everything together. Volume means how much space an object takes up. It can also mean how much space is inside an object. Area is flat. Volume is solid. Area is like covering a surface. Volume is like filling a space. To measure volume, we use cubes. 1 cubic centimetre is a tiny cube. It is 1 centimetre long, 1 centimetre wide, and 1 centimetre high. It is useful for small objects. 1 cubic metre is a big cube. It is 1 metre long, 1 metre wide, and 1 metre high. It is useful for large objects and large spaces. For a cuboid, like a box, we find the volume by multiplying length, width, and height. Volume equals length times width times height. For a cube, all sides are equal, so we find the volume by multiplying side, side, and side. Volume equals side times side times side. The most important idea is this. Volume is not just the bottom. Volume is the whole space. It includes length, width, and height. So next time you see a pencil box, a lunch box, a drawer, a cupboard, a bottle, or a room, you can ask, how much space does it take up? That is volume. And if volume feels difficult, remember the cube idea. Imagine filling the object with small cubes. Count the cubes in one layer, then count how many layers there are. That is the heart of volume. Once you understand that, the formula becomes much easier.